Right, so moving on from balancing chemical equations, let's take a look at aqueous solutions and solubility. So first off, what does aqueous solution mean? Again, that just means that it's dissolved in water. And then solubility is the measure of how much of it will dissolve in water, right? We can't put an unlimited amount of compound into water. Eventually, it's not going to dissolve. And some compounds will easily dissolve into water, and other compounds will rarely or basically not at all dissolve into water. So basically, what we're asking about solubility is, will it dissolve? And in general, if the answer is yes, then we say that it's soluble. And if the answer is no, it's not going to dissolve, then we call that insoluble. So an example of something that would dissolve is what's known as strong electrolytes. And strong electrolytes fully dissociate in solution. So what we're talking about here is ionic compounds. And when we say dissociate, that means that the ions separate. So for example, if you put some salt in water, some sodium chloride into water, it's going to split up into cations of Na+ and then anions of Cl-, right? So let's just draw a little rudimentary picture of that, right? We've got a cup of water. We're going to toss in some NaCl. It's a terrible arrow. Toss in some NaCl, and what's going to happen is that the NaCl will dissolve. And then what's happening on a molecular level is that there's just ions freely floating around. They're no longer really bonded to one another. And the reason that we call this an electrolyte is because this solution, when it has ions in it, will conduct electricity. We won't go into deeper details than that, but later on in your other chem classes, you will, right? So strong electrolytes will fully dissolve. And then if a compound is insoluble, it won't dissolve. So for example, if we had a cup of water and then we tried to toss in some silver chloride, some AgCl, that AgCl would just clump down on the bottom and it would not dissolve at all. We just have a solid down on the bottom of our cup of water. And so how do you know whether something's going to dissolve or not? It's basically just a lot of chemical intuition, which we obviously don't have as an intro class. So I definitely don't expect you to memorize any of this, but I expect you to be able to use a chart that looks like this. So this is the chart that I'm going to provide you in the module. I don't expect you to memorize this, but I expect you to be able to use it. So the questions we can answer is, will blank dissolve in water? Right, we're talking about here is water. And water is important to us because we live on Earth, which is mostly water. We're humans that are also mostly made out of water. So let's take a look at some examples. Let's take a look at sodium chloride. Note that there's two different headers in this table. These compounds up here are mostly soluble, so these will dissolve, and then their exceptions are right there. And then the second part of the table is these compounds are mostly insoluble, so these won't dissolve with the exceptions right there. So first off, we need to go from the name to the chemical formula. So sodium chloride would be NaCl. And then you just want to find your components. So we have Na right there. We have Na+. And notice that it's in the mostly soluble side, and there are no exceptions. So for the vast majority of sodium salts, they are soluble. So the answer here is yes, sodium chloride will dissolve, which I hope you know because that's just table salt. Then we have calcium carbonate. So again, we want to go from the name to the chemical formula. Calcium is Ca2+. Carbonate is one of our polyatomic ions, which is CO3 2-. And then we want to find our compounds in this table. So we have calcium over here. I don't see calcium anywhere in these ions. So let's go to the next part of the equation, which is this carbonate, CO3 2-. I check out my ions here, and then I see CO3 2- right there. Note that it's in the mostly insoluble side. So it's insoluble unless it's paired with lithium, sodium, potassium, or ammonium. calcium is not any of those things. So in this case, it will not dissolve because we're in the mostly insoluble side. So will it dissolve? No, it will not dissolve in water. And then finally, let's take a look at silver bromide. Silver gets the symbol Ag, and it always has a charge of +1, and then bromine is Br minus. So our formula here is AgBr. Let's take a look at our first component, silver. I don't see silver anywhere there, so I'm going to go to the next part of my component, which is our bromide, our Br minus. We have Br minus right there. It's in the mostly soluble side with some exceptions. So then we take a look at our exceptions. It says insoluble when paired with silver, right? So we have it paired with silver here. So in this case, it's going to be insoluble. So will this dissolve in water? No, it will not. Again, I don't expect you to memorize this chart. You're going to be given it, just be able to use it.